Lithography machines are indispensable tools in the chip manufacturing industry. ASML, a Dutch company, holds the distinction of being the world's largest manufacturer of lithography machines. Notably, they are the sole entity mastering the mass production process of EUV lithography machines. ASML's journey to this point, marked by its remarkable success, has been significantly shaped by globalization. In the world of photolithography machines, there exists a crucial dependency on certain components without which manufacturing would be impossible. Despite external sanctions affecting Russia, the country has ambitious plans to independently develop photolithography machines. Furthermore, there have been reports indicating that Russia has created manufacturing tools capable of substituting photolithography machines, taking ASML by surprise. In the ongoing chip war initiated by the United States, photolithography machines have become a pivotal breakthrough. Restricting the shipment of high-end photolithography machines has made it challenging for competitors to create advanced process chips. Lithography machines primarily employ optical projection technology to project chip design patterns onto silicon wafers, forming intricate graphics and circuit structures. In essence, lithography machines play a pivotal role in chip manufacturing, significantly impacting chip performance and accuracy. EUV lithography machines, in particular, comprise over 100,000 parts, with over 5,000 suppliers from around the world involved in their production. ASML's ability to build these machines hinges on global collaboration, drawing upon top technologies from the United States, Japan, the United Kingdom, and other countries. Notably, there are only a few lithography machine manufacturers globally, and not all companies can muster the necessary global strength. Even with the support of relevant top suppliers, manufacturing lithography machines remains a complex endeavor. At the heart of any lithography machine lies its optical system, which demands high-precision lenses and optical components to achieve pattern projection. These optical components necessitate specialized techniques and equipment for manufacturing and installation to ensure optical system performance and stability. The production of photolithography machines involves multiple process steps, including material selection, processing, assembly, and debugging. Each of these steps requires stringent control of process parameters and quality standards to guarantee the performance and reliability of the entire photolithography machine. ASML's lithography machines are renowned for their exceptional quality and enjoy recognition from customers worldwide. Replacing ASML lithography machines is no small feat, but Russia has chosen a different path, one of self-research and development. Despite facing sanctions from European and American countries, Russia has made significant efforts to develop its own chips and laid out corresponding plans for lithography machines. In March of this year, Russia allocated substantial funding for the development of photolithography materials for microelectronics production. Additionally, Russia strongly supports local chip manufacturing projects. Given Russia's scientific capabilities, it is entirely plausible for the nation to develop precision equipment such as photolithography machines. Indeed, recent reports from Russia suggest significant progress. Researchers at St. Petersburg Polytechnic University have made a breakthrough in photolithography technology. They have developed a domestic photolithography complex capable of etching and producing maskless chips. This technology eliminates the need for traditional masks, substantially reducing time and costs in the chip manufacturing process. Traditionally, during the chip manufacturing process, a photolithography machine employs ultraviolet light or lasers to project patterns onto a mask, which is then transferred to the semiconductor material, creating the structure of the microelectronic device. However, without a mask, this photolithography step cannot be completed. Russia's innovation involves bypassing the need for masks and employing software control for automation. Russia's approach is not merely to copy ASML's lithography machines, but to forge a new path in creating similar technology, achieving the same goals in its unique way. St. Petersburg Polytechnic University's expertise in micro-nanoelectronics positions it well to master the ability to replace traditional lithography machines. ASML's unanticipated situation underscores the potential impact of Russia's efforts. If Russia succeeds in developing chip manufacturing equipment with lower prices and superior performance compared to ASML's lithography machines, it could lead to a significant reshuffling of the global lithography machine industry. The emergence of such tools in the market could result in ASML losing a substantial number of orders, with the United States and Western countries actively seeking Russian chip manufacturing tools. However, it's essential to recognize that these expectations are speculative. Realizing this vision requires the creation of tools that can genuinely replace photolithography machines. While Russia possesses top-notch scientific capabilities, questions remain about whether its funding, industrial chain support, and other factors can keep pace with its ambitions. The road ahead for Russia's lithography replacement journey remains uncertain, and the world watches with interest. As Russia continues to strive for self-reliance in chip manufacturing, it faces various challenges and opportunities. One of the key challenges is the global landscape of sanctions and restrictions. Russia has been a subject of external sanctions, particularly from European and American countries, for various reasons, which have significantly impacted its access to products such as chips and photolithography machines. These restrictions have forced Russia to reevaluate its approach to chip manufacturing and pursue self-sufficiency. One of the critical components in chip manufacturing is photolithography machines, and their production has traditionally been dominated by a few key players, with ASML being the prominent leader in the field. ASML's lithography machines are known for their high quality and precision, making them an industry standard. However, Russia has chosen a different path, one that involves developing its own domestic solutions. In March of this year, Russia allocated substantial funding, approximately 1.1 billion rubles, for the development of photolithography materials for microelectronics production. This investment demonstrates Russia's commitment to achieving self-reliance in chip manufacturing, as it seeks to reduce its dependence on external suppliers. Additionally, Russia is strongly supporting local chip manufacturing projects, further emphasizing its dedication to building a robust domestic industry. The recent breakthrough at St. Petersburg Polytechnic University in photolithography technology is a significant milestone in Russia's journey towards self-sufficiency in chip manufacturing. The development of a domestic lithography complex capable of etching and producing maskless chips represents a departure from traditional methods. Instead of relying on masks, this technology leverages software control for automation, potentially reducing both time and costs in chip manufacturing. While these developments are promising, it's essential to acknowledge the challenges that lie ahead. The global semiconductor industry is highly competitive and relies on intricate supply chains and collaborations with various global partners. Achieving self-reliance in manufacturing complex equipment like photolithography machines requires not only technological advancements, but also sustained funding, access to critical materials, and a supportive industrial ecosystem. Russia's journey towards replacing traditional lithography machines is an ambitious undertaking that has the potential to reshape the industry. If successful, it could introduce chip manufacturing equipment with better performance and lower costs than ASML's offerings, disrupting the status quo. This could lead to ASML losing a significant share of its market and create opportunities for Russia to become a major player in the global lithography machine industry. However, it's important to temper these expectations with the understanding that achieving such a feat is no small task. The development of photolithography machines involves intricate details, stringent quality standards, and complex manufacturing processes. ASML's expertise and reputation have been built over years of research and innovation. Russia's path is not about copying ASML, but about finding its unique approach to achieving similar goals. St. Petersburg Polytechnic University's role in this endeavor is significant. As one of Russia's top scientific and engineering institutions, it has the expertise and resources needed to push the boundaries of photolithography technology. The university's breakthrough represents a step in the right direction, but there are still many unknowns on the path to replacing traditional lithography machines. Russia's pursuit of self-sufficiency in chip manufacturing, particularly in the development of photolithography machines, is a bold and ambitious endeavor. It highlights the nation's determination to reduce its dependence on external suppliers and assert its presence in the global semiconductor industry. While there are challenges and uncertainties ahead, the progress made at St. Petersburg Polytechnic University and the investments in photolithography materials demonstrate Russia's commitment to this journey. The world watches with anticipation to see how this path unfolds and whether it will indeed lead to a reshuffling of the global lithography machine industry. What potential impacts do you foresee if Russia succeeds in developing chip manufacturing equipment that can replace traditional lithography machines, both in terms of the global semiconductor industry and geopolitical dynamics? Engage with us by leaving a comment, subscribing to our channel, and clicking the notification bell for regular updates. Keep watching, stay inspired, and get ready for more exciting discoveries. See you in our next episode.